The Aurora Borealis, also known as the Northern Lights, is a natural wonder that has fascinated humans for centuries. It occurs when charged particles from the sun interact with the Earth's magnetic field and atmosphere to produce beautiful, colorful displays in the sky. But did you know there are actually 5 hidden facts about the Aurora Borealis that not many people know? In this video, we will be revealing these 5 hidden facts about the Aurora Borealis forecast that will blow your mind. So make sure to watch till the end. Number 1. Aurora Borealis can be predicted using a 27-day cycle. The Aurora Borealis is influenced by the sun's activity, which follows a 27-day cycle. Every 27 days, the sun's magnetic field flips its polarity, which results in an increase in solar activity. During these periods, there is a higher chance of seeing the Aurora Borealis as the increased solar activity leads to more frequent and intense geomagnetic storms. To predict the occurrence of the Aurora Borealis, scientists use a scale called the KP index, which measures the severity of geomagnetic storms. When the KP index is high, it indicates a higher probability of seeing the Aurora Borealis. Number 2. Solar flares and coronal mass ejections are major factors. Solar flares and coronal mass ejections are sudden and intense eruptions of solar material and energy that can trigger the Aurora Borealis. These events can cause a disruption in the Earth's magnetic field, leading to an increase in the energy and intensity of the Aurora Borealis. Scientists use various tools, such as the Solar Dynamics Observatory and the Solar and Heliospheric Observatory, to monitor these events and predict their impact on the Earth's magnetic field. By studying the frequency and intensity of solar flares and coronal mass ejections, scientists can better understand the factors that contribute to the Aurora Borealis and improve the accuracy of their forecasts. 3. Space weather can influence the intensity of the Aurora Borealis. Space weather refers to the conditions in the Earth's upper atmosphere and space environment caused by the sun's activity. It can significantly influence the intensity of the Aurora Borealis. For example, during periods of high solar activity, the Earth's magnetic field is more likely to be disrupted, leading to more intense and widespread Aurora Borealis displays. Additionally, the density and temperature of the atmosphere can affect the way the Aurora Borealis appears. During geomagnetic storms, the Aurora Borealis can become more intense and reach lower latitudes. However, it is important to note that space weather is a highly dynamic and unpredictable phenomenon, and its impact on the public. Aurora Borealis can vary widely depending on various factors, such as the strength and duration of solar activity. Number 4. The Kyoto scale is used to classify the intensity of the Aurora Borealis. The Kyoto scale is a 3-letter scale used to classify the intensity of the Aurora Borealis based on the size and brightness of the solar-induced nighttime glow in the sky. The scale ranges from a low of KP1 to a high of KP9, with KP9 being the most intense. The scale is based on the planetary K index, which measures the disturbance in the Earth's magnetic field caused by solar activity. The Kyoto scale is particularly useful for predicting the visibility of the Aurora Borealis at a given location. For example, a KP6 or higher is necessary for the Aurora Borealis to be visible at mid-latitudes, such as in Norway and Sweden. On the other hand, at high latitudes such as in Alaska and northern Canada, a lower KP value may be sufficient to see the Aurora Borealis. It is important to note that the exact threshold KP value for aurora visibility can vary depending on factors such as atmospheric conditions and light pollution. 5. Aurora Borealis can be seen in other planets' atmospheres. While the Aurora Borealis is commonly associated with Earth, similar phenomena have been observed in the atmospheres of other planets, such as Mars, Jupiter, and Saturn. These planetary aurorae are formed by the interaction of charged particles from the Sun or the planet's magnetic field with the planet's atmosphere. For example, Mars has a thin atmosphere and weak magnetic field which makes it susceptible to solar wind. As a result, Mars experiences frequent and intense Aurora Borealis displays that can be seen from the surface. Jupiter and Saturn also have strong magnetic fields that interact with the solar wind and their moons. These interactions produce bright and complex Aurora Borealis patterns that have been observed by spacecraft such as Voyager, Galileo, and Cassini. Studying these planetary aurora can provide valuable insights into the composition and dynamics of their atmospheres and magnetic fields. There you have it, folks. 5 hidden facts about the Aurora Borealis forecast that not many people know. We hope you enjoyed learning about this fascinating natural phenomenon and the science behind it. If you want to learn more about the Aurora Borealis or other similar topics, we have a lot of content on our channel. Make sure to check them out. Don't forget to subscribe and hit the bell icon so you never miss out on any future videos. Thanks for watching, and we'll see you next time.